Here, connected particles, considering two particles of masses m1 and m2, where m2 is greater than m1, connected by like inextensible string passing over a smooth pulley. So that means that if the particle, let me say this is a pulley, and here I have, so here this is our m1, this is our m2. This is our M1. Now here there is a weight, which is M2G. There is a weight of this particle, which is M1 what G. Now if M2 is greater than M1, automatically in the system, this will move up with acceleration A, this will move down, this mass will move down with acceleration, which is A. It's the same acceleration since it's the same system with one string, okay? So if that's the case, we shall look at cases for M2 and for M1. Say for M2 kilogram, we shall now say the resultant force here. That means that there is a string here, there is tension here, there is also tension here. It is the same tension because it is the same string. So for M1, that since it is moving up, it means that it will be T. For M2, sorry, this one is greater than this, so it is M2. Horizontal force will be equal to M2A minus tension. But remember, F is same as M1A. So M2A, okay, is equal to, okay, M2A is equal to M2G. This is G. M2G, okay, minus T. So now in this case, we can now say that we call that equation what? Equation 1. Equation what? Then for M1. For M1 mass, for a body of mass M1, tension is moving up, so the resultant force will be equal to T minus M1 what G, which is M1A, that's the force equal to MA, is equal to T minus M1 G. That's equation what 2. Now from the 1 and 2, by adding them, 1 plus 2, tension will disappear. So we shall have M2A plus M1A, giving us, when you add this plus this, you have M2G minus M1G. It is a tension which has disappeared. So acceleration into M2 plus M1 is equal to G into M2 minus M1. So what is our acceleration? Will become G into M2 minus M1 divided by M2 plus M1. You get that? So that is how acceleration can be obtained. Let us go and look at examples. Okay? We look at examples. Look at examples. We go to number what? Example number 1. What do we say? So we have this example. Example number 1, two particles of masses 5 kg and 10 kgs. So we have this system. This is our pulley. We have two particles. This is 5 kg. This is 10 what? Kg. So this is 10g. This is 5 what? 5G, okay. This is the 10 kg, the other is. Then the tension here is T. The tension here is T. Then this is 10 is greater than this one, so this one is pulling downward. Acceleration A is A. This one acceleration is going where? Up. In that direction. So we shall start case 1 for 5 kilogram. So it is going up, so T minus 5G is equal to M what? MA. MA, that's 5G. 5 equation 1. Then here we shall have this going down, that's 10 minus 10G minus what? Minus T should give us 10 what? Our force, which is the MA, is equal to the equation of 2. So subtracting, when you add this it is 10G minus 5G will not become add. This is 15A. So our A will become, this is 5G over 15, which will become 5 times 9.81 divided by 15. And what we get as our acceleration? Our acceleration becomes 3.27. 3.27 meters per watt per second squared. So from equation what? From equation 1, we substitute T minus 5 times 9.81 is equal to 5A, that's 5 times 3.27. So our T will not become 5 times 3.27 plus 5 times 9.81. What will be our tension? Our tension becomes 65.4 newtons. That is the first one, the first episode. So we have this one. These are tracks which are pulling each other. Now these tracks which are pulling each other, so we have track A and track B. So let's say this is the road. So we have, let me say this is the track what? This is one track. This is another track. So let me say this is the engine force. The force, it is this one which is pulling this A, this is it, B. So it is pulling like that, okay? And then I'm saying that that the force exerted is, this force of the track is 8 what? Newtons. And I think that this one has a mass. So there is a normal action here. We can call it R1. Here to be M1, G. Then here I can call it R2. This is M1, M2, M2G. So they are saying the frictional force, okay? The frictional force, they have told us that the frictional force of motion on A is if the frictional force on motion, frictional force of motion on A is 1,000 and on B is 2,000. 1,000 Newton and on B is 2,000 what? Tons. So that means that since the motion is in this direction, the frictional force, the force that opposes, will be in the opposite direction of the motion. So this one has a frictional force here, which they have given us as on A is 1,000. Okay. Then here, the frictional force of this one is 2,000. On B, it is 2,000. So we shall now say case 1 for A. Now when you look at A, when the A is moving forward, okay, since the A is moving forward, then we shall say the exact tension. Here there is tension here. This is tension. It's one rope, right? So it means that 800. So the direction of the motion is like this. The acceleration is like that. Okay. So 800 minus. Now here we have two forces. We have T plus 1,000. Now this arrow you are seeing is for this one. It is the other side. Then this arrow in the tension is for this one. So you see how those two arrows are facing each other. So is equal to MA. So this one A mass is what? For A the mass is 1,000. So this is 1,000. So meaning that this is 800, okay, minus T plus 1,000 gives us 1,000 watt. So this is 1,800 minus T should give us 1,000. Okay, point equation what? 1. Then for B here it has tension minus 2 what? 2000 should give us MA. Our mass is 3000. Yeah. So this is equation what? 2. So we're going to eliminate it. How do we eliminate it? We add, okay? So we shall have 1000 like this, okay? 800 minus, so here we are adding, so this is minus 2000 should give us, so we add this becomes, this is 4000, but there is a mistake in terms in what? We are going to get a negative acceleration, but negative acceleration means they are decelerating, okay? Yeah, but I think there was a mistake there. It is 8,000, not 800. It is 8,000. The pulling force is 8,000 because 800 cannot overcome these forces. Okay? 800 cannot overcome these forces. So the pulling force, this is 8,000. So when you add this, becomes 90,000. Like that. So this is 90,000. So meaning that our A will become, this is 7,000 divided by 4,000, so which becomes 1.25. So I'm seeing. So okay, another mistake was here. When you open brackets here, you get negative. Okay. When you open brackets, then here this becomes 7. This becomes 7. 7 minus this becomes 5, which gives us 1.25 meters per second. Then we substitute from 2 our tension will become 3,000 times 1.5. Then plus what? Plus 2,000. So what will be our tension? Our tension becomes 5750. 5750 newtons. That is it, our tension. So that is example number what? Number 2. Let us go and see example number 3. So we have this. We are saying that a mass of 9 kilograms resting on a smooth table. So we have this is smooth table. A smooth table, and have a mass is here 9 kilogram, and then it is connected to another. It's connected to another one this side, which is what? Which is 7 kilogram hanging freely. So there is tension here. Now here there is also what? There is tension here, T. Now this one we have 9G, this is reduction, then here we have 7G. So what we shall do is, we shall now say that of course, we expect the acceleration to be in that direction. When you suspend this mass, obviously, it pulls this mass, not so. So acceleration is in that direction. So for 7 kg, we shall now say 7G minus T, giving us A, 7 times A. Equation 1. Then for 9 kg, we shall say that now here we have 0. The frictional force is 0, not so? So we can say T minus 0 is equal to MA, which means T will be equal to MA, which is 90A. That's equation 2. So put 1 in 2. Put 1 in 2. Put 1 in 2. We shall now say 7G minus 9A is equal to 7A. So 7G will become 16A. So meaning that meaning that our A will become 7 times 9.81 divided by 16, which gives us what now? So this one will give us acceleration as 4.29. Gives us 4.29 meters per square squared. Then the other one says find the tension. So then the question 2 from 2, our tension T will become 9 times 4.29. Now what we get here as tension? The tension will be 38.63. 38.63. Then next is find the force on the pulley. So you have the pulley, this is the pulley, and you have the force. This force here is tension. Another one down here is also tension. Also, so they want you to find this force on the pulley. How do we get this force here? How do we get to that force F? So we shall use what? So F, so meaning that it's like a triangle which has opposite as T and adjacent as what? T. So be a square root of T squared plus T squared, which will become square root of 2T squared, okay? Which is this is a T square root of 2, which will now become 38.63 square root of what? 2. So what do we get in this case? So our force will now become 54.60 newtons. Okay, so can we go and look at it now? So this is number 3, showing us that these are masses which are connected using like inextensible strings. So you can see 20 kilogram mass is connected to 16 kilogram mass, and then 20 still is connected on 8 kilogram mass using what? Inextensible strings. So now I want to look at what we do. Let's do the double again, so that we have something like this. This is our 20 kilogram. Here we have our mass, which is 16 kg. This is 8 kg. Like that. So here we shall have, let's say, this is 16 g. Then this one is what? This is 8 what? G. Now, since 16 kilogram is bigger than 8, we expect the motion to go where? The motion to come this way, with acceleration there. Since the same system, it will be the same acceleration. Then here, like that, acceleration is in. Now, the tension here, we shall have, let's call this one T1. Let us call this one T1. Then here, we shall call this one, okay? This is T1, T2. So it has T2 is here, like that. So we start with from here. We say for 8 kilogram. Since it's moving up, we shall now say that T2, okay, minus 8B should give us MA, which is 80. Equation 1. Then for 20 kgs, we have now to move in that direction, so it's T1 minus T2, giving us 20, equation 2. So for 16 kgs, we shall have 16g minus T1, giving us 16 what? Equation. So we are going to solve those equations simultaneously, and we get the value for A. So from 1 and 2, can we eliminate T2? From 1 and 2, okay? From 1 and, we can say equation 1 plus or minus 1 to eliminate T2, so that's a plus equation 1, equation 2. So when we add, we shall have T2 will disappear, we shall have T1. T1 plus 8G, that's minus 8G, giving us add this is 28 what? 28. That's equation 4. So find 3, what do we do? What do we let T1? Find 3 we add. Equation 4 plus equation 3. Okay? So we're going to add. When you add, this will disappear. We have 16G plus 8G. 16G plus negative 16G, now minus 8 what? 8G, okay? Will become, when you add the 28 plus 16, you will get 44. So this is 2B is equal to 44. Okay? So our A will become 2 times 9.81 divided by 44. So what will be our acceleration? Use a calculator. Do you get something like 8 times what do you get here? This is 8. This is 8. This is 8. So what do you get? You get something like 1.784. 1.784 meters per second squared. So that's saying that find the tension, part 2. Find the tension of 16. So this one, what T1? T1 substitute in what? In 4. From 4, our T1 will become what? This is 28. Times 1.784 is plus 8G plus 8 times 9.81. So what is our T1 now? What will be our T1? Our T1 when you substitute become is it plus? I think is it plus? Yeah, plus. So what do you have as our T1? Our T1, I'm seeing we are going to have T1 as 128.41. 1.8.41. What about T2? Because we are going to calculate this. What? Let me remove this one. Then T2, how do you get T2? Then from what? From 2. From 2, our T2 will become what? Our T2 will become T1 minus the 20A. T1 is 128.41 minus 20 times acceleration 1.7 what? 84. So what will be our T2 now? So our T2, we shall get 92.75. 92.752 newtons. Use the calculator and see what we get. Then after that, they are asking us to get the normal reaction. The normal what? The normal reaction. So let's say reaction on each pulley. Let us consider this one. Here we have this is the pulley. This is down here. So we have the reaction here. This is the reaction, and this is T2. This is T1, T2. Okay. So how do you get that reaction? Of course, if you do like this, you realize that reaction is like that. So to get it, you shall say that our reaction is T2 squared plus T2 squared under square root, which is T2 square root of 2, which is our T2 is 92.752 square root of what? Over 2. So when you substitute, what do you get? You get, so we can recall that one as R2, okay? And that's 92. So the answer will become 141. This is R2. 141.171. 171. Now for the other one, it's like this. This is a T1. This is a T1. So the normal reaction is this one. That's R2. So here, to get this normal reaction, this is the result between the two forces. So normal reaction R2, we've already said that it is T1 square root of root 2. which becomes 1 third what? 128.41 root of 2, which gives us 131. Is it true? 181.6. 181.6.1 newtons. So I think we can put exercise, not so. So we have this is exercise. Two particles are connected like this. Now when these two particles are connected, and maybe they say you have the particles which are connected like this. This is a pulley, and you have the string down here. The tension it is here, and then the tension it is here. So now if you have now the resultant is here. This is now the normal reaction. So what happens if you have these two? If your forces are in the same direction, so to get if the forces are in the same direction, what do? You add the forces to get the resultant. Not so. So the normal action here, which will be the resultant force, will be the force on the pulley will be the summation of these two tension. T1 tension plus tension, so you get to T. Okay. So now we have motion on an inclined plane. We consider a plane which is inclined at an angle alpha. Let us have a plane inclined at an angle alpha. So this is the plane. It is inclined at an angle alpha. Let us make theta, and this is it. Now this one has the reaction. This is which is always perpendicular to the surface, and then you have the weight. The weight is that thing vertical downward. This is the weight of the body, which is m1 mg. Now, when we are going to resolve, okay, so we are going to get the components, the component of the weight. So we have the normal reaction, then we are going to have resolve the components of weight. So we are going to look at this one, so this angle here. Now what get this one and horizontal component. Get this horizontal component. Now the angle is also theta. This angle is theta. So let us check. If I have, let me say, I have this. This is, let me say, I've got this one 1. Then we got y maybe. Then we got a. Then here I have this one. Then this is weight mg. Then here horizontal. The one which makes negative is this one. This one, let me go to B, Let me go to B, like that. So this one is part of this, okay? It's part of that. So you realize that it makes negative with this, So it's what you're calling what B. This one, that one, they are the same, okay? So the angle is theta is here. So if I get, like, for example, say sine of theta. So our is our adjacent. Our adjacent is this. Okay? If this makes 90, then 90 is here. This is perpendicular to this one. That means it is like this. It is here. Okay? So what is our adjacent? Adjacent will now become this one. The opposite, the hypotenuse. Opposite, so this is opposite, that is B divided by hypotenuse, which is mg. So B will become mg sine theta. So I'm saying that now this line here, okay, and this line here, they are perpendicular. Not so. See that now that means that if I draw another line here, which is part of this, it will be parallel lines, meaning that it will also be perpendicular here, isn't it? So if I use sine, then I'll be able to get my B as mg sine theta. So the resolved component here will be mg sine theta. Then what about cos? Cos of theta will be equal to adjacent, which is A. This is adjacent A, divided by hypotenuse, which is mg. So our A will become mg cos of theta. Where is our A here? Our A is this one. So this will be mg cos of theta. Where mg sin theta and mg cos theta are the resolved components of the weight of the body. The resolved components of the weight of the body. bad. So here, what I'm going to do now, and those of the components, we call them the weight of, okay, the weight anyway, the weight. So let us look at now some examples. Let us look at examples which involve using that. We look at some examples that we are going to use this concept here. Is that okay? So we have one example which says that a rectangular box of mass is pulled from rest along a smooth incline plane. So like this. So they're saying that find the acceleration. So in this case, what you do, you have to do like this. This is incline. Let's do it here. Let's say the box is here. This is a pulley. So this is it. So in this case here, we shall have first the weight here. The weight is 20 G. Then the tension is up this side. So here we shall have the tension is like this. Then down here, this side we have the resolved the component of what? Of weight. So we have this. Then we have this. This is R. This is mg. This is 10 G. This will be 10 G cos of 30. Cos of 30. This is R 30 degrees. What about this one? This will be 10 G sine of 30. So since this one is not than this one, then the motion is like this. The motion is along the what? Along the incline. So from here, we can start with maybe for 10 kgs, for 10 kilogram mass. So the motion is upward, so that's a T minus 10 G sine 30, giving us 10A. Then equation 1. Then for 20, we shall have 20 G minus T, giving us 20 what? Giving us 20, equation 2. So 1 plus 2, 1 plus 2, you realize that this is 20 G minus 10 G sine 30, giving us, that is 30. So our A will become 20 times 9.81, okay, minus 10 times 9.81 sine of 30 divided by 30. So what is our acceleration? So we shall have the answer for our acceleration as, let me see, our acceleration is 4.905 meters per second. Then the other question was asking about the tension. So then you can substitute this one here. You can say from 2. So this is 20 minus T, 20 G, sorry, 20 G. Is equal to 20 what? 20 substitute. So our thing become 2 times 9.81, that's 20. Then minus 20 times 4.905. So when we substitute properly, we shall be able to get our tension as 98.1. 98.1 newtons. Okay, is it okay? 98.1. We can have a next. So we have this exercise. A truck of mass 900 kilograms pulls a caravan of mass 70 kilograms along a level road. The engine of the truck exerts a forward force of 2,400 and there is no resistance to the motion. Find the acceleration produced and the tension in the rope. So that is the exercise that you can do. yeah, exercises you can do.